morning. I, Bhavna, Faculty, School of Finance and Commerce, Gulgottius University, Greater Noida, is going to give a presentation on the topic Assignment Problem. Assignment problem, as we know that it is a particular case of the transportation problem where the objective is to assign the number of resources to the equal number of the activities so as to minimize the total cost to maximize the total profit. The problem of assignment arises because of the available resources like men, machine, etc. They have their varying degree of their efficiency for performing the different activities. Therefore, the cost and the profit of performing the different activities are different. So let us learn more about the assignment problem in this video. The following are the prerequisitions for studying the assignment problem. Before studying the assignment problem, one should know the meaning of the cost and profit, as we are going to assign the various activities in the assignment problem to maximize the total profit. The following are the objectives. The first objective is to understand about the assignment problem. The second objective is to make you clear about what are the various steps which are required to solve this problem. The third objective is to make you understand the concept of the assignment problem with the help of the practical questions. Now, what is an assignment problem? Assignment problem is a special class of the linear program because it involves determining the most efficient assignment of the people to the project, of salesperson to the various territories, various contractors to the bidders, and so on. For example, we are having 4 sales territories and we are having the different salesperson. We should assign each territory to each salesperson so that no territory should be left out and there should be no duplication of the territories. So, in order to solve the assignment problem, we used to minimize the total cost or the time which is required for performing the task. So, one important characteristic is that we are having only one job which needs to be assigned only to the one machine. So, in assignment problem, we used to keep the following things into the consideration. The first fact is the duplication of efforts, and all the resources should be assigned and no resource should be left out. Let us understand what are the various steps which are required for solving the assignment problem under the Hungarian method. The first is to develop the cost table for the given problem. If the number of rows are not equal to the number of columns, or the number of columns are not equal to the number of rows, then a dummy row or the dummy column must be added. The assignment cost for the dummy cell is always 0. The next is to find out the opportunity cost table. Locate the smallest element in each row of the given cost table, and then we have to subtract that from each element of that row. In the reduced matrix, then we have to locate the smallest element in each column that need to be subtracted from the other elements of that particular column. Note, each row and each column will now have at least 0 value. The next is make assignment in opportunity cost matrix. We have to examine the rows successively until a row with exactly one unmarked 0 is obtained. Make an assignment single 0 by making a square around it. And for each 0 that become assigned, you have to eliminate all other zeros in that same row or in that same column. Then we have to continue this process until all the zeros in the rows and columns are either enclosed or stuck off. The next is optimality criteria. If the members of the assignment cell is equals to the number of rows and columns, then it is the optimal solution. The total cost is associated with the solution by adding the original cost figure in the occupied cell. If the 0 cell is obtained, then it will be closed as given in step 2. The next is revise the opportunity cost table. After optimality criteria, we have to find out that from each row in which there is no assignment has been made, and we will mark a tick. Then we will be examining the marked row. If any 0 occurred in those columns, then we have to take the respective row that contains those assigned 0. Then we have to repeat the process until no more rows or columns can be marked. And then we have to draw a straight line through each marked column or each unmarked row. The next is we have to develop the new revised opportunity cost table. For this, for amongst the cell which has been not covered by any line, we will choose the smallest element and we are going to subtract that element, smallest element, from every element in that cell which has been not covered by the line. And we are not going to make any changes, and all the elements in the cell covered by one line, it will remain unchanged. And we are going to repeat the same step if we are not obtained with the optimal solution. So these were the various steps which need to be followed for solving the assignment problem. Let us understand the assignment problem with the help of this practical question. In this practical question, a case study has been given to us. A company has 5 jobs to be done by the 5 workers. Job 1, job 2, job 3 and job 4 up to till job 5. Then the company has the number of hours each workers take to complete the job is given with the help of this matrix table. Workers W1, W2, W3, W4 and W5 has been given to us. Now we have to solve this problem with the help of the assignment. Let us understand this case study with the help of assignment problem. For solving the assignment problem, we need to follow the certain steps. The first step is to find the minimum element in each row and to subtract it from all elements of that particular row. Like in this question, in the first row, the first element that is going to be subtracted is 24, because 24 is the minimum element in the row 1. So 24 is going to be subtracted. So 28 minus 24, 27 minus 24, 24 minus 24, 37, 35 minus 24 and 38 minus 24. As similarly in the second row, we will be looking that what is the smallest element. In the second row, the smallest element is 23. So 23 will be subtracted from the other elements of that particular row, like 26 minus 23, 24 minus 23, 23 minus 23, 32 minus 23 and 39 minus 23. Then we are going to write down the answers. After that, in the third row, we need to look the smallest element, which is 18. So 18 minus 18, which is 0, 20 minus 18, which is 2, 22 minus 18, which is 4, 30 minus 18, which is 12, and 32 minus 18, which is 40. Now we have to look for the row 4. In row 4, the smallest element is 24. So we are going to subtract the smallest element 24 from the other row elements. Like 27 minus 24 is 3, 30 minus 24 is 6, 25 minus 24 is 1, 24 minus 24 is 0, and 27 minus 24 is 3. In the fifth row, we will be looking for the smallest element, which is 28. So we subtract this 28 from the other column. So here we get the total matrix by subtracting the smallest element from each row and subtracting it from all the elements of that particular row. First step was to find out the minimum element in each row. But in the second step, we will be finding out the minimum element in each column and we will subtract it from all the elements of that particular column. Like in first column, we are having the minimum value, which is 0. Taking into consideration the previous matrix, we can see that the minimum element is 0 in column 1. So we are going to subtract the minimum value from the other corresponding values of this column. Like 4 minus 0 is 4, 3 minus 0 is 3, 0 minus 0 is 4, 3 minus 0 is 3 and 1 minus 0 is 1. In second column, when I look, I find the minimum value 1. So I am going to subtract this minimum value 1 from the other values of that particular column. So 3 minus 1 is 2, 1 minus 1 is 0, 2 minus 1 is 1, 6 minus 1 is 5 and 3 minus 1 is 2. The next is, in third column, I find this is 0 is the minimum element. So I am going to subtract the 0 in all the values of column 3. 0 minus 0 is 0, 0 minus 0 is 0, 4 minus 0 is 4, 1 minus 0 is 4 and 0 minus 0 is 0. In column 4, I will be looking for the minimum value. Looking up the previous matrix table, in that I was having the minimum value 0. So I am going to write down the new values. That will be 11 minus 0, 11, 9 minus 0, 9, 12 minus 0, 12, 0 minus 0, 12 and 12 minus 0 is 12. Similarly, in the column 5, I will be finding out the minimum value. In column 5, with respect to the previous matrix table, I find that the value 3 was minimum. So I subtract this minimum value from all the values given in column 5. That will be 14 minus 3 is 11, 16 minus 3 is 13, 14 minus 3 is 11, 3 minus 3 is 0 and 8 minus 3 is 5. So this is how my new matrix table will be prepared after subtracting the minimum elements from each column. Now I have to find out in step 3. Start from row 1. Now in step 3, if the optimal assignment is not formed, then we have to cover the maximum zeros. So let us learn that how we can cover the maximum zeros. As you can see, in first column we are having this 0. In second column we are having this 0. In column third we are having this 0 and in column fourth we are having this 0. As we can see that assigning of the assignment problem will be only when we are having each 0 to be assigned among the each resource. But here we will be not able to locate the sufficient amount of zeros. Why? Because in row 4 you can see that we are having 0 in row 4 and the same 0 is there in row 4 with respect to column J5. It means that the same worker that was worker 4, he cannot work on job 4 or job 5 at the same period of time. A worker can perform a job differently. He can either work in job 4 or he can work in job 5. But if we see that a worker 4, he has to work in both the jobs because 0 is coming in this W4, which is not possible. So, it means that the optimal assignment problem cannot be formed here. So, we need to cover the maximum number of the zeros. Let us cover that. In first column, let us cover this column by the straight line. In second column, let us shade this 0 by forming a straight line. In the third column, let us cover the 0 by forming a straight line. We need to cover the maximum zeros. So, I need to cover this 0. For that, I cannot make a column straight line because ultimately it will lead to finish my matrix, and it is the wrong way of doing it. Why? Because I need to assign the maximum zeros. So, I will be assigning the 0 by taking into consideration that we need to first cover the maximum number of zeros. So, I will be making a straight line over here to cover the maximum 0. So, these are my left element and these are my uncovered elements. First, we need to ensure that all the zeros are covered with the minimum one line. And then we have to find out the minimum elements which are not covered by any line. So, in this matrix, we find the minimum element which has been not covered by any of the line, it is 5. So, the 5 is the minimum element and we need to take this element into the consideration as it has not been covered by any line. Then, in step 5, we will be subtracting the minimum element from the elements which are not being covered by the line. Note down this, that the lines which are intersecting, we will be adding the same element 5 to those intersecting lines, and we will be not changing the lines which has been already been covered. So, I am going to subtract this minimum value from of 5 among the various uncovered elements. So, in the first row, that was W1, the minimum element 5 is going to be subtracted from the uncovered element, which was 6, which leads to the values 6 and 6, that is 11 minus 5 and 11 minus 5. In second row, if I see, the 3 was the covered elements and the remaining 2 was uncovered. So, I subtract the minimum value 5, that will be 9 minus 5, which is 4, and 13 minus 5, it is 8. In row 3, I find that the first 3 elements was the covered elements. So, I am going to subtract this value 5 from the uncovered element, which is 12 minus 5, which is 7, and 11 minus 5, which is 6. Then, I will be looking for the intersecting line. As you can see in row 4, we are having the 3 intersecting lines which is meeting at the same point. So, 5 will be added. in that intersecting points. So 3 plus 5 is 8, 5 plus 5 is 10, 1 plus 5 is 6, and we are going to put these values 0. In row 5, we find that the first tree element has been the covered element. So I am going to subtract the minimum value 5 from the uncovered element of that row. That will be 12 minus 5 is 7, 5 minus 5 is 0. Now after following step 3, we are going to cover all the elements with the straight line again. And since the 5 lines are being formed, so the optimal assignment can be made. Now we have to assign each job to each worker. As we can see, in the first job, the assignment will be made on to the worker 3, which will be at this point. That will be 0. In column 2, that will be J2. J2 job will be assigned to the worker 2. Why? Because it is having a 0 assignment over here. Then in column J3, worker 1 will be assigned. Then it will be going to be put in the square line. In column J4, the job will be assigned to the W4, that is worker 4. In the fifth column, the job will be assigned to the worker 5, that is W5. So, we have assigned each job to each worker. J1 is assigned to W3. J2 is, that is job 2, is assigned to W2, that is worker 2. Job 3 is assigned to worker 1. J4, that is job 4, is assigned to the worker 4. And the job 5 is assigned to the worker 5. Now, you will be looking at what values we have been taken. These values have been taken from the first table which has been given to us in the question. So, I am going to put those values which I have taken from the first table. Like in first table, was having this value W3 in J1 column, it was 18. In second column, I was having, in the initial table, I was having this value 24. And in the third J3, I was having the first element in the initial table, it was 24. Similarly, in job 5, it was 24, and in job 4 and 5, it was 24 and 36. So, this is how we have assigned each job to each worker. Like J1 job is assigned to the worker 3, J2 job is assigned to the worker 2, J3 is assigned to the worker 1, J4 is assigned to the worker 4, and J5 is assigned to the worker 5. Along with that, we are going to take the values which we have taken from the initial table, which has been given to us according to the values assigned. So here the minimum total time is 126 hours. So this is how the optimal solution is unique, because this solution is optimal itself. Neither it is having any type of scarcity, nor it is having any type of duplications. I hope that this video on solving the assignment problem will be helping you to assign the different types of the resources among the different types of an activities. We are having many more practical examples in this video. So you can study and you can also practice the different practical questions in order to understand the concept. Thank you for watching this video.